Hey guys, and welcome back. Now that we have our pipeline kind of set up here, or at least we've got Canico working, of course you could create a fully automated pipeline where you run kubectl every single time that you commit changes to your repository. It's kind of outside the scope of this particular skill. We're really just exploring exactly how Canico works. But let's go ahead and make a change to our application, create a new version, and then we'll go ahead and just deploy that out to ECR, and then we'll create a pod on our Kubernetes cluster using that new container image. So what we're going to do is in our project here, I'm just going to go into my server, and then we'll change it to say, welcome to my about CBT Nuggets PowerShell web application. And we'll save that, and we'll just commit the server.ps1 file. We'll say updating web server, and push that up to GitLab. And then what we want to do is in our Canico YAML file that we're using to run Canico, we need to, everything else is going to pretty much stay the same here, but we'll just change the version number here to like v2. For example, of course, you could use like a semantic versioning system or whatever versioning system you want to for your actual container image tags here. But I'm just going to use v2 for now to indicate a new version, and everything else is just going to stay the same. We're still connected to GitLab, we're still connected to ECR through the AWS credentials. So all I really need to do at this point is to just remove my Canico configuration here from my Canico 2 namespace, and we'll just do another apply on it to re-trigger it, and that should all run fairly quickly. Let's just do logs on it, and then the other thing we can do is just kind of keep an eye on the Elastic Container Registry over here, so you can just kind of refresh here and wait for that new v2 image tag to pop into your ECR environment. Let me just kind of refresh this here, and if we take a look at the logs, sure enough, it is running successfully here. Just give it a couple of more seconds to complete. Usually one of the slowest steps in this particular application is actually running install module, just because that PowerShell is kind of slow at installing modules from the PowerShell gallery. But now you can see we've got a new version here. It says it's untagged. Let me just do another refresh here, see what's going on. Not quite sure why that's happening. It says pushing image to v1. Oh, and that's because, of course, I didn't save my file here. All right, well, that's what happens when you don't save things. So let's do a delete, and then we'll just do another apply here. Give it a couple of seconds to rebuild. Right, and we'll just verify that that is updated here. All right, so now we've got a v2 tag. So what we can do is actually deploy this v2 tag out to our Kubernetes cluster, of course. So what we're going to do is come back to VS Code here, and I'm just going to create a new file here. We'll just call it deploy pod.yaml, and I'm just going to declare a pod inside of here. And I'm just going to give it a name. Actually, let's do a deployment. So let me do a Kubernetes deployment just so it has a little bit more robustness to it. And I'm going to change the name to Posh Web App. And of course, it'll update all the labels, which is really convenient for me here. And then down here under my image, that's where I want to grab my ECR path here and paste that in. That'll be the image that we're going to deploy from, which is the v2 tag. And then down here under container port, we'll just do port 80. And let's see, what else can we update here? So this is looking pretty good. I think we could also add in some replicas. And you can see in the Kubernetes documentation, the deployment object or resource has a replicas property here. So we'll add that in, say replicas, about maybe 6. We'll spin up a whole bunch of instances of this application. And I'll also add in a service, and for the service, I'll set the name to, let's call it Posh Web App, and the selector is going to need to match the labels down here. So the app is going to be Posh Web App, and that'll be our selector. And then for port, we'll expose on port 80, and we'll expose that on internal port 80 to the containers. And I'm also going to set the type to load balancer, and that should provision a cloud-based load balancer. So let's give this a try. We'll do kubectl apply, namespace, Canico 2, and then we'll do -- file name and say deploy pod.yaml. And I think I got the syntax right on those. So yeah, those got created. And I'll fire up my trusty Lens utility here. If you don't know what Lens is, it's a really sweet user interface that you can use to connect to your clusters and view different workloads. So I'm going to go to my cluster here, go down to workloads, and we'll take a look at, let's say, pods here. Go down to pods, and then we'll change our namespace to Canico2. And you can see that we've actually spun up 6 different pods here as part of a deployment replica set. And then that should be exposed as a service. So I'll come down under network, go down to services, and sure enough, we've got a load balancer type service here, and it should have allocated a DNS name. So down under external IPs here, got a DNS name. And so I should, in theory, be able to connect to that load balancer on port 80 and connect to all of my endpoints. So the service controller has actually registered all of my 6 pod endpoints with itself. So let's try to access this. We'll go to that DNS name on port 80, and sure enough, it is up and running here. So we've got a cloud load balancer that was created thanks to the service controller, and the service controller was able to register all of my endpoints with it. And so now we've got a highly available application here from a private container image that we are hosting on Elastic Container Registry. I hope this has been informative for you, and I'd like to thank you for viewing.